This is section 7.1, Introduction to Circles, and for part A, we're looking at number 5 from the homework. Here we're identifying the center and the radius. The center we get from the -8 and the +3. We take the opposite of what it is in parentheses. So it's a -8, so we're going to put a +8. And we have a +3, so we're going to put a -3. And then to get the radius, we're going to end up taking the square root of 80. If we're graphing this, well, first we can break down 80 to 4 times 20. And 20 is 4 times 5. And so we can simplify the square root of 80 to 4 square root 5. But when we're graphing this, it's nice to have some sense of a decimal value to know exactly how long this radius is. So if we enter this into a calculator, we get roughly 8.9. So in graphing this, we first start with our center at 8, -3. Plot our points. And then our radius is 8.9. So from the center, we're going to go 8.9 in every direction. So 8.9 to the left, and then 8.9 above the center, roughly here. And then 8.9 to below the center, kind of off the grid here, and then 8.9 to the right of the center. And then we sketch our circle the best that we can. And there we have it. So the next one, part B, we're taking from number 10 on our first homework. And we're to write the equation of the circle with the given information. The circle is shifted from the origin 4 units down with a radius of 3√2. So we want to get our center of the circle, and our radius is given to us already at 3√2. Our center, well, since we started at the origin and we moved 4 units down, we're going to be at, well, first I'm going to write the radius here. Radius is given at 3√2. And our general form of our equation, if we have a center A, B, and a radius R, is going to be x minus a squared plus y minus b squared equals r squared. So we know our center, because we shifted 4 units down, is going to be at 0, -4. And our radius is given at 3√2. So we plug in our values, and we get x minus 0 squared plus y minus -4 squared is equal to our radius, 3 square root 2 squared. And we just need to simplify this a little bit. x minus 0 is just x, so we get x squared. Y minus negative 4 is a y plus 4 squared. And then when we square 3 square root 2, get 3 times 3, which is 9. Square root 2 times square root 2, which is 2. And so we can finish this by writing x squared plus y plus 4 squared is equal to 18. And there's our equation. Our next problem is taken from number 12 in our homework. And it's asking, is the point 2, 4 inside, outside, or on the circle x plus 1 squared plus y minus 1 squared equals 16. So from the equation we can see that the center is going to be at negative 1, 1. We can also see that the radius is going to be the square root of 16, which is 4. And so let's sketch this circle. Left 1, up 1 for our center. And then go 4 in each direction, to the right, above, to the left, and below the center. There's our circle. And we're interested in the point 2, 4. So when we plot that point, we can see where it is in relation to our circle, which is pretty close to our circle. So our circle, our drawing may be off a little bit. The way I drew it, it looks like it's outside the circle, but I may be incorrect. We need some more information. We need a more definitive way to answer this question, because I don't have that much confidence in my drawing. So notice we're given the point 2, 4, and we're going to plug in 2 for x and 4 for y into our equation. See what value we get, and let's compare it to 16. So 2 plus 1 is 3. 3 squared plus 3 squared is going to give us 9 plus 9, which is 18. So that's greater than 16. So how do we interpret this? What does that mean? Is it inside? Is it outside? Is it on the circle? Well, if you get a greater than sign like what we have here, that's indicating that the point we're looking at is outside the circle. If we get an equal sign, it indicates that the point is actually on the circle, which is on the circumference of the circle. If we get a less than sign, then it indicates that we're inside the circle. And so in our case, we have a greater than sign, which means we're outside the circle. And the last one that I'm going to go over is number 17 from the homework. It says to complete the square and write the trinomial as a perfect square, no decimals are allowed. So we're going to, in order to come up with the number that we need to complete the square, we're going to take negative 20, which is the number in front of x, divide it by 2, or cut it in half, and then square it. When we divide it by 2, we get negative 10, and negative 10 squared is 100. So that's the number we need to add to both sides of the equation. The reason this number is so special is so that when we factor, we get 2 of the same factors, or a perfect square. what two numbers multiply to 100 and add to negative 20? Negative 10 and negative 10. So we get x minus 10 times x minus 10 is equal to negative 2 plus 100, which is 98. So we finish this by writing x minus 10 squared, because there's two of them, is equal to 98. And that's the end of the problem. Okay, this is number 2 is taken from second homework, and part A is number 1 from the second homework, or second worksheet. And we're asked to convert the following circle equations to descriptive form by completing the square, identify the center and the radius, and to sketch the circle. So we're going to use completing the square. To do that, we want to group our x's together. So we have x squared and a minus 10x. We have a, I'm going to leave a little space, positive y squared minus 4y. And everything else, any constants, I'm going to move to the right side of the equation. So we have that negative 20, positive 20. I'm going to subtract 20 to make it equal to negative 20. And now I'm going to complete the square twice. First, for the x values, there's a negative 10 in front of the x. So I take the negative 10, cut it in half, and then square it. So half of negative 10 is negative 5. When you square that, you get 25. So 25 is what we want to add to complete the square for the first part. Whatever you add to the left side, add to the right side as well. And then we want to do this again for our y values. We want to take the negative 4, square it, cut it in half first and then square it, and we get negative 2 squared, which is positive 4, and that's what we're going to add to the y terms. Whatever you add to the left side, add to the right side as well. And now we factor. When you factor the x terms, you get x minus 5 times x minus 5. When you factor the y terms, you get y minus 2 times y minus 2. So on the right side, negative 20 plus 25 is 5. 5 plus 4 is 9. So this is x minus 5 squared plus y minus 2 squared is equal to 9. So from our equation, we see that the center of our circle is at 5, 2, and the radius of our circle is the square root of 9, which is 3. And so we can sketch our circle here by first plotting the center at 5, 2. And then from the center going 3 in each direction. And there we have it. The part B is taken from number 9 from our homework, which is to convert the following circle equation to descriptive form by completing the square. Identify the center and radius, and again sketch the circle. So it's the same, it's asking us to do the same thing that we did in the last problem. The only difference here is we see this big fraction, and you may be curious, well, how do we do this with a fraction like this? So first, start the same way, group the x values. So we got the x squared and the 8x. Leave a little room to complete the square. We got our y value, which is y squared. And then all constants move to the right hand side. So negative 319 over 25. And then begin completing the square. So we take the 8, cut it in half, and square it. Half of 8 is 4, 4 squared is 16. That is what we need to complete the square. So we add 16 to both sides of the equation. We factor x squared plus 8x plus 16 factors to x plus 4 times x plus 4. We have a y squared, which we didn't need to complete the square because there wasn't any y term, just the y squared term. And then we want to begin working out or adding the fraction with 16. So negative 319 over 25 plus, we had 16 over 1. I'm going to multiply top and bottom by 25. 16 times 25 is 400. So now we have x plus 4 squared plus y squared equals 400 minus 319 is 81 over 25. And so that's the equation of our circle. From that we get the center of our circle, which is at negative 4, 0. And the radius of our circle, which is the square root of 81 over 25. The square root of 81 is 9. The square root of 25 is 5. So 9/5. If you change that to a decimal, you get roughly 1.8. So now we can sketch that. Center at negative 4, 0. Go roughly 1.8 in each direction. Something like that. All right. Number 3 is coming from section 7.3, the definition of a parabola from the focus in Directrix. This is part A is taken from number 1 from our worksheet or our homework. It says to graph the parabola x squared equals 16y. First step here is to solve for y. And so I'm going to swap 16y and x squared. And it's really a 1 times x squared. And then divide by 16. And you end up with y equals 1 over 16 x squared. So from this equation we can see the vertex, or find the vertex. The vertex is going to be 0, 0, because we don't have any number with the x in parentheses. We don't have any number added or subtracted after the x squared either. We just have that 1/16, which we're multiplying by x squared. And that doesn't shift the parabola left or right. So we know we have a vertex at 0, 0. That 1 over 16, though, is equal to 1 over 4a. Or in other words, that 16 we can set equal to 4a. And find out that a is 4. A is the distance from the vertex to the focus. And that's going to be helpful with our graph here. So let's graph our vertex at 0, 0. Our focus, well, here our parabola we know is going to open up for 2 reasons. First, it starts with it's a y equals, and the y-axis goes up or down, and so we know it's either going to open up or down. And second, that 1/16 is positive, so we're opening in the positive y direction. So the focus always goes in the direction of the opening. So it's going to be 4 units above our vertex. So I'm going to labels. I'll put F next to focus. I'll put V next to vertex. And then the directrix is on the opposite side of the vertex, the same distance. That distance A from the vertex. So I'm going to go down 4 and to sketch our directrix. So the directrix is, in this case, a horizontal line. The vertex is dead center between the focus and the directrix, a distance of 4 away from both. So we can now put our focus here at, the coordinate of our focus is 0, 4. The equation of our directrix, it's a line, it's a y equals -4. Make sure you have y equals, not x equals. And the focal chord endpoints, well, we're going to use a to help us find that. Actually, 2 times a, well, a is 4, so 2 times a is 8. That's the distance from the focus to the parabola in this case, moving left or right. So from our focus, I'm going to go right 8 and left 8. So 1, 2, 3, 4, 5, 6, 7, 8. And left 1, 2, 3, 4, 5, 6, 7, 8. And so we have this parabola here opening up. So it's a bowl shape. The focus is always inside that bowl. The directrix is somewhat like the table that the bowl sits on. And so we have our 2 points. The one on the left is at -8, 4, and the one on the right is at +8, 4. Part B is taken from number 7 in the homework, and it says to use the formal definition of a parabola to derive the equation of a parabola with a focus at 0, 4 and a directrix at y equals -4. So I'm going to start with a sketch here. So the sketch is going to have y equals -4. So there's our directrix. And our focus at 0, 4. And we need to use the formal definition of a parabola. The formal definition is the set of all points equidistant from both the focus and the directrix. So one point in particular we know is the vertex is the same distance from both, and then it just creates this parabola here. Something like that. So we'll pick a generic point on our parabola, point P, which is some generic x and y. And here's our focus, which is at 0, 4. And the distance right here, I'm going to use a different color. So here's a segment from F to our point here. And then I want to draw the distance from that point to our directrix, which is going to be a straight drop down. So let me redraw this so that it extends a little further. And so here, right there, that's on the directrix. The directrix is the line y equals 4. But that particular coordinate where they touch here is going to have the same x value, which we don't, it's just a generic one, with a height of -4. And and we'll call that point D for the point on the directrix. And so by our definition, we know that the distance FP is going to equal the distance from P to D. Now using the distance formula, point F, you subtract your x values, so x minus 0 squared plus y minus 4 squared, that's my FP right there, is going to equal the distance from P to D. So that x minus x squared plus y minus negative 4 squared, double negative. Remember the distance formula in general between, let me write this out here, the distance formula between x1, y1, and x2, y2, the distance between them, d, is going to be the square root of the quantity. You subtract your 2x values squared plus you subtract your 2y values and square it. So that's what we're using to find these, to set this equation up. And so from this equation we're going to be able to derive our equation. So square both sides to get rid of the square root. And we have x minus 0 squared plus y minus 4 squared is equal to x minus x squared plus y minus negative 4 squared. And then there's a few other things we can do. We know that x minus 0 is x, so this is just an x squared, plus y minus 4 squared is equal to x minus x is 0 plus another y, well here we have a y plus 4 squared. And so now multiply out our y minus 4 squared. So this is x squared plus y minus 4 times y minus 4 is equal to y plus 4 times y plus 4. Y minus 4 times y minus 4 is going to give us, so we got x squared plus y squared minus 4y minus 4y plus 16 is equal to y squared plus 4y plus 4y plus 16. So a few things we can cancel out here. We could subtract 16 from both sides. We can also subtract y squared from both sides. And now we're left with x squared minus 4y is equal to 4y plus 4y. Actually, I left a minus 4y out. So let me put that in there. Scoot that over a little bit. So that's x squared minus 8y is equal to 8y. Add 8y to both sides, you get x squared is equal to 16y. Swap sides. That's a 1 in front of the x squared. That's invisible. I'm going to write it there so that when we divide by 16, we get y as 1 over 16 x squared. You may notice this is the same exact problem we had in number 1. Number 4. This is from 7.4, sideways parabolas from the Focus and Directrix. And this is taken from worksheet 4, and we're going to look at number 4 and number 6 from that worksheet. So number 4, or part A, says to graph the parabola y squared equals 3x and find the focus, directrix, and focal chord endpoints. So here we have a y squared. So we need to solve for the variable that is not squared, which is x. So I'm going to turn things around. I'm going to put the 3x on the left side and the y squared on the right side. There's a 1 in front of that y squared that we usually don't write, but I'm going to write it there so that when we divide by 3, we know it's going to end up being x equals 1 divided by 3 y squared. So that's the equation we're going to work with. If you have a parabola that starts with x squared, it's going to open along the x-axis, meaning it's going to either open right or open left. Because that 1/3 in front of the y squared is positive, we're going to open to the right. Also, we can get the vertex pretty easily here. The y is not in parentheses with a number. Also, there's no number added or subtracted after the y squared, so this has a vertex at 0, 0. And then the number in front of y squared, the 1/3, is equal to 1 over 4 times a. Because both numerators are 1, we can say that 4a is equal to 3, giving us a is 3 over 4. So a, that 3 over 4, that's the distance from vertex to focus. Okay, so we have some information to start our graphing. So vertex is at 0, 0. The focus is in the direction that it opens. We said we're opening to the right, so we're going to go to the right of the vertex 3/4. So it's pretty close to 1. So 3/4 is between 0 and 1. There's our focus. And so the location of that focus is 3/4 to the right. That's our x value, 0 for y. The directrix is the opposite side of the vertex, the same distance away. So 3/4 to the left of the vertex, we have the directrix, which is this line. And the equation of the directrix is going to be x equals, all vertical lines are x equals, and negative 3/4 is the x value it goes through. Then if you take a and multiply it by 2, so 2 times a, which would be 2 times 3/4, we work that out, we get 6 over 4, reduce that to 3 over 2, or 1.5. That is the distance from the focus to both sides of the parabola. Kind of gives the width of the parabola at the length of the focus. So from the focus, I'm going to go above and below 1.5. So from the focus, I'm going to go up 1.5 and below 1.5. And then we have that. Those 2 points that I just graphed are called the focal chord endpoints. So the one above is going to be at x value is 3/4. The y value was 3/2. and then the one below was x value had 3/4, y value had negative 3/2. Number 6, or part B, which is from number 6 on the worksheet, says to make a sketch and use the formal definition of a parabola to derive the equation in vertex descriptive form for the parabola with a focus at -8, 0 and the directrix x equals 8. So I'm going to sketch what's given first. So x equals 8. That's a vertical line going through 8 here. And focus is at -8, 0. So over here, -8, 0. So our vertex is at 0, 0. And it's opening towards the focus. Pick a generic x, y value here. And by definition of a parabola, the distance from the focus to a point is going to be the same distance from that point to the directrix, which has an x value of 8 and a y value at whatever the y value of that point is. So that's I'll call that point D. So we know that FP is equal to PD. So the distance from F to P is equal to the distance from P to D. Using the distance formula, point F has an x value at -8. Actually, sorry, I'm going to start with P and then go to F. So P has an x value of x minus the x value -8 from F. Square that, plus P has a y value of y minus the y value of F squared is equal to P has a x value minus the x value of D squared plus y minus y squared. So you're just plugging into the distance formula, square both sides, and you get x plus 8 squared plus y squared is equal to x minus 8 squared plus 0. So this is x plus 8 times x plus 8 plus y squared is equal to x minus 8 times x minus 8. Keep working through this. When you multiply x plus 8 times x plus 8, you get x squared plus 8x plus 8x plus 64 is equal to, I forgot my plus y squared, sorry. Is equal to, now multiply the x minus 8 times x minus 8. And there's some things we can cancel out. They both have an x squared that we can get rid of. And they both have a 64 that we can get rid of. And so we have 16x plus y squared is equal to -16x. Subtract 16x from both sides. We get -32x. I'm going to switch sides. So -32x is equal to y squared. Remember, there's a 1 in front of that y squared. So divide by -32, and you get x is equal to -1 over 32 y squared. And that's your answer. Number 5 is from section 5 on transformations of parabolas. This first problem, part A, is taken from worksheet 5, and it's number 4 from that worksheet. And it says to graph the parabola y equals 1 over 20 x squared plus 4 Find the graph of the vertex, focus, directrix, and the focal chord endpoints. First of all, it is already solved for y, which is what we want. It's in terms of x squared, and if it's a y equals parabola, it's going to open along the y-axis. The y-axis opens up and down, so this parabola is going to open up or down because of that y equals. To know if it opens up or down, we look at the number in front of x squared, which is positive 1 over 20. Positive means you open up in the positive direction. Negative would be the other way. So we know our parabola is going to open up. The vertex is going to be 0, positive 4. And the vertex comes from, there's no number with the x squared in parentheses, so the 0 value of our 0 is our value for x in our vertex, and that plus 4 is where we're getting our y value for our vertex. So I'm going to plot our vertex at 0, 4. And now I want to find the focus. We know that that number 1 over 20 is equal to 1 over 4a, where a is the distance from the vertex to the focus. So from that we can say, well, that means that 4 times a is equal to 20, and a is going to equal 5, because you divide by 4. So that's our distance from the vertex to the focus. And our parabola opens up, so I'm going to move 5 in the above the vertex, which is off of our graph here. So up 1, 2, 3, 4, 5. That's our focus. That's going to be at 9 on the y-axis. So our focus is at 0, 9. Our directrix is going to be 5 below the vertex, which is at negative 1. And it's the equation y equals, any horizontal line starts with y equals, and the height is going to be negative 1, so y equals negative 1. Lastly, we want our focal chord endpoints. They're going to be lined up with the focus, and to find out how far from the focus they are, you take a and you double it. So 2 times a is 10. So we're going to go 10 to the right of the focus and 10 to the left of the focus. So if I go 10 to the right of the focus, I'm at 10, 9. If I go 10 to the left of the focus, I'm at negative 10, 9. And so my parabola opens from the vertex through those focal chord endpoints. The focus is always inside your parabola. The directrix is always on the outside, on the opposite side of the focus. The next problem is taken from number 5, from worksheet 5. And here it's not in the form that we want. We need to decide to either solve for y or to solve for x. You solve for the one that's not squared. And we see the exponent 2 with the y plus 2, so we're going to leave that as is, and we're going to solve for x. Don't distribute that negative 3. Instead, I'm going to switch things around, and I'm going to write it above here. So I'm going to put negative 3 in parentheses x minus 1 is equal to y plus 2 squared. There's an invisible 1 in front of the parentheses, so I'm going to divide by negative 3, and I get x minus 1 is equal to negative 1/3. times y plus 2 squared. And then I want x by itself, so now I'm going to add 1 to both sides. And so the equation I want is x equals negative 1/3 times y plus 2 squared plus 1. So everything's going to come off of that equation. First of all, notice it's an x equals parabola, which because it starts with x equals, it's going to open along the x-axis, left or right. Then because it starts with the negative 1/3 in front, it's opening in the negative x direction, which is a left opening parabola. So opens left. I'm going to take note of that. Secondly, I'm going to get the vertex. You have that y plus 2. The 2 goes with the y value, so it's the y value of your vertex, but it's the opposite of what you see there. So you got a plus 2 there. You're going to put a minus 2 in your vertex. The plus 1 is going to be your other value. In this case, it's going to be our x value, and don't change that one. So I'm going to plot our vertex at 1, negative 2. We know this thing's opening to the left. I'm not going to sketch it yet, but that tells us that the focus is going to be to the left of the vertex. I'll label this V for vertex so I keep track of things. And to find out how far the focus is from the vertex, I'm going to take that negative 1/3, and actually we can ignore the negative. I'm just going to take 1/3, and I know that's equal to 1 over 4 times a, which tells me that 4 times a is going to be equal to 3. Divide by 4, you get a is 3/4. So it's pretty close to the vertex. I'm going to go to the left 3/4, not even a full unit, so 3/4 right there. That's my focus. And that location, well, if I was at 1 and I went to the left 3/4, I'm at 1/4. Still at the same height of negative 2. And the directrix is going to be 3/4 to the right of the vertex. And it's going to be a vertical line. And it's the equation x equals, well, I was at 1 plus 3/4. So 1 3/4. Or if you want to write it as an improper fraction, you can say 7/4. Lastly, we want our focal chord endpoints. So we take A and times it by 2, which is 2 times 3/4, which is 6/4, when reduces to 3/2, or 1.5. So we're going to go 1.5 above and below the focus, because these are going to be lined up with the focus. So 1.5 above the focus, 1.5 below the focus. And our parabola is going to go through those points. They just kind of give you a sense of how wide this parabola is. Focal chord endpoints always line up with your focus. The coordinates of those, the one above, is going to be same x value as the focus, so 1/4, and then negative 1/2. Because I was at negative 2 and I went up 1.5, so I'm going to be negative 1/2. And then the one below it is going to still be at x is 1/4, and a negative 2 minus another 1.5, so negative 3.5, or negative 3.5. And now we have all the pieces we were looking for. So lastly, we're going to look at number 7 from worksheet 5. It says make a sketch and use the formal definition of a parabola to derive the equation in descriptive form for the parabola with a focus of 2.21 and a directrix at x equals negative 2. So starting with our sketch, 2, 1, it's right here. That's our focus. And then x equals -2. That is a vertical line going through -2 for our directrix. Now our vertex, we need to know our vertex is directly in between the focus and the directrix. So it's going to be here at, so we have a vertex at 0, 1. So, and we know it's opening to the right. And if we pick a generic point, I'll put point P, which is xy. We have our focus, which is 2, 1. And the distance from the focus to that point is going to be the same distance from that point straight to the directrix. So I'll call that point D, which would be at -2 y. And the definition of a parabola says that the distance between a generic point and the focus is going to be the same distance between our generic point and the directrix. Using the distance formula, x value from our point is P, x value from the focus, the x value from the focus is 2, so x minus 2 squared, plus the y value from our point P minus the y value of our focus, which is 1. So that represents the distance from point P to F. And that's going to equal the distance from P to D, so x minus -2 squared plus y minus y squared. So we work this out. Square both sides. You get x minus 2 squared plus y minus 1 squared is equal to x plus 2 squared plus 0. Right, that's gone. So when you have 3 binomials that are squared, you're only going to want to multiply 2 of them out and leave the other one alone. The 2 you're going to want to multiply out are the 2 that have the common variable. So here we have 2 binomials that have an x. So those are the ones we want to multiply out because we'll get an x squared from each of those and we can cancel the x squared out. Don't multiply out the one that just has one variable because it's not going to cancel out with anything, and it's going to be less work if you leave that in factored form. So we're going to multiply the x minus 2 with itself. We're going to leave y minus 1 squared alone, and we're going to multiply x plus 2 with itself. And when we multiply things out, we end up with x squared minus 2x plus 4 plus y minus 1 squared is equal to x squared plus 2x plus 2x plus 4. And you see we can subtract x squared from both sides, subtract 4 from both sides. And now we're left with -2x minus 2x plus y minus 1 squared is equal to 2x plus 2x. So that's -4x plus y minus 1 squared is equal to 4x. Add 4x to both sides. Switch sides. Don't forget there's an invisible 1 in front of the parentheses here, so when you divide by 8, you end up with x is equal to 1 over 8 times y minus 1 squared. And that is our equation for the parabola. And we derived it using the definition of a parabola. Number 6 is taken from section 6, converting parabolas from general to descriptive form. And part A is from number 2 on our worksheet 6. It says to identify the direction the parabola opens, complete the square to write the equation in descriptive form, and include the parabola's vertex. So notice we got two variables, x and y. The one that's squared is the y term. So we want to solve for x. It's already solved for x, which is nice. And so now all we need to do is to get it into the correct vertex form. So first of all, we're going to focus in on the two terms that include the y. And so if there's a number in front of y squared, you need to factor it out of those two terms. So I'm going to factor out a negative 5, and I get negative 5 times y squared plus 6y plus 4. Okay, and you can always check to make sure you did this right by going back and distributing, saying, okay, well, if I multiply negative 5 times y squared, do I get negative 5y squared? Yes, we do. And negative 5 times 6y would be negative 30y, and you got the plus 4 tagged on at the end. So we haven't changed, we haven't made a mistake. Everything's good. We're getting ready for it to be put in its correct form. So next, we want to complete the square. We look at the 6 in front of the y. Make sure you factor out that negative 5 before you complete the square. So you take that 6, you cut it in half, and you square it. And that gives you the number that you want in order to complete the square. So it's going to be 3 squared, which is 9. So I want to add a 9 there. Okay. But when I add 9 inside the parentheses, its value is really negative 5 times 9, which is negative 45. So I have subtracted 45 by putting that 9 there. So I need to do the opposite on the outside. I need to add 45 to compensate for subtracting for the 45. Next step is to factor. Y squared plus 6y plus 9 factors to y plus 3 times another y plus 3. And then 45 plus 4 is 49. And we have two of the same factors, so this is y, so x equals negative 5 times y plus 3 squared plus 49. And now it's in our vertex form. This is going to open in the negative x direction. It starts with x equals, so it's opening along the x-axis. It's got a negative 5, so it's in the negative x direction, so it's going to open to the left. So opens left. For a vertex, we have a y plus 3 squared. So that 3 is going to give us our y value. We take the opposite of what's there, and so our y value becomes negative 3. The 49 gives us our other value, which in this case is the x value. Don't change the sign of the 49 though. So we were asked to identify the direction of the parabola. We did that. We completed the square, and we included the parabola's vertex. Let's go to the next problem. Next problem, part B, is taken from number 7 on our worksheet, and we're asked to do the same thing that we did in part A. So we start by looking at the negative 3x squared plus 12x. We make sure whatever's in front of x squared we factor out of that part. So we're left with x squared minus, changes the sign, minus 4x, and leave a little space, plus 13. Okay, so that negative 3 we're only factoring out of the first two terms, not touching that 13. Complete the square. Half of negative 4 squared is going to give us negative 2 squared, which is 4. So 4 is what we want to add inside the parentheses. Because there's a negative 3 in front, that really has the value negative 3 times 4, which is negative 12. So by putting the 4 there, we're subtracting 12. We need to do the opposite on the outside, add 12 to balance the equation. So we go ahead and factor from there. We get negative 3. We factor this to x minus 2 times x minus 2. And then add the 13 and 12 and get plus 25. Because we have two of the same factors, we can write that as x minus 2 squared plus 25. This is going to open down, the parabola will, because it's a y equals parabola, opens along the y-axis, and a negative 3 opens down in the negative direction. Our vertex is going to be 2, 25. The 2 is with the x value, x minus 2, and so we know the 2 contributes to our x value in the vertex. It's always the opposite, and then that 25 contributes to the other one, in this case the y variable. Number 7 is taken from section 7 on converting parabolas and circles to descriptive form. Part A is number 1 from our worksheet. And we are wanting to graph and fill out some other information in regards to this problem. So it's the x minus 3 that's being squared. We want that on the right side of the equation. Whatever's being squared should be on the right side. So I'm going to flip this around. 8 times y minus 5 is equal to, in parentheses, x minus 3 squared. Remember, there's a 1, invisible 1 in front of that parentheses, so when you divide by 8, don't distribute the 8, divide by 8, you end up with y minus 5 equals 1 over 8 times x minus 3 squared, and then finish by adding 5. So y is equal to 1/8 times x minus 3 squared plus 5. That's the descriptive form that we want to use to find all the missing pieces. Starting with our vertex, that minus 3 contributes to the x value, because it's with the x in there, and the 5 is our y value. So I'm going to plot that. And label it with a V for vertex. This parabola is going to open up. And I know that because it starts with a y equals, so it's opening along the y-axis, and because the 1/8 is positive, so it opens in the positive y direction. Our axis of symmetry, well, I'll get to that. So the line of symmetry, I'll come back to that. The focus comes from taking that 1/8 and setting it equal to 1 over 4a. So 4a is equal to 8, a is equal to 2, and a is the distance from the vertex to the focus. And because our parabola is opening up, we're going to go up 2 units from our vertex. and so that's going to be at 3, 7. Sorry, that's the focus, not the line of symmetry. Let me correct that. The directrix is on the opposite side of the vertex. In this case, it's a horizontal line. Again, 2 units from the vertex, the same distance, the vertex to the focus. And so this is going to be the equation y is equal to 3. And the focal chord endpoints line up with the focus, one on the right, one on the left in this case, and have a distance of 2a from the focus, which in this case is 2 times 2, or 4. So from the focus, I'm going to go right 4 and left 4 from the focus. And my parabola goes through the vertex and through these focal chord endpoints. And the one on the left is going to be located at -1, 7. The one on the right is going to be located at 5, not 5, sorry, at 7, 7. And lastly, the line of symmetry cuts through the focus and the vertex. That's what the line of symmetry is. And so this is going to be x equals 3. And now we have all the pieces we want for that problem. On to the next one. So here on part B, the y plus 2 squared is on the left-hand side. And we want to move it to the right-hand side. So we want to switch sides. By the way, this is taken from number 2 on worksheet 7. So when we switch sides, we end up with 4 times x plus 1 is equal to, in parentheses, y plus 2 squared. Don't forget there's an invisible 1 in front of the parentheses, so when you divide by 4, you get x plus 1 is 1/4 times y plus 2 squared, and then subtract 1. And we have the form that we want to work with. It should look like that. Okay, so here it's going to open in the positive x direction. So it opens right. We say positive because the 1/4 is positive. We say x direction because it's an x equals parabola. The vertex of this parabola, well, that y plus 2 contributes to the y value of the vertex. So we get a -2 for the y value, and the -1 contributes to the x value. So we can start by plotting that vertex at -1, -2. The focus, we need to take that 1/4 and set it to 1/4a, which tells us that 4a is equal to 4, a is equal to 1. So the distance from the vertex to the focus is 1, and we're opening right, so we're only going to the right one. So we have our vertex here, we got our focus there. And that is going to be at 0, -2. Put it in the wrong place again. Let me fix that. The directrix is located on the opposite side of the vertex, same distance away, so this vertical line x equals -2. The focal chord endpoints line up with the focus and are a distance of 2a from the focus, which in this case is 2 times 1, or 2. So 2 above the focus and 2 below the focus, and our parabola goes through the vertex and those focal chord endpoints located at 0, 0, and 0, 4. Lastly, our line of symmetry always passes through the vertex and the focus, which is the equation y equals -2. Part C is taken from number 8 from our worksheet. And here we need to do a little work to get it into the form we would like. I'm going to factor a 2 out of the first two terms to start. So y is equal to 2 times x squared minus 14x, leave a little space to complete the square, plus 98. When completing the square, we take the -14, cut it in half, and square, which is -7 squared, which is positive 49. So we want to add 49 inside the parentheses. But 2 times 49 is 98. So by putting a plus 49 there, we're adding 98 that wasn't there. So we need to compensate by subtracting 98. Then we factor and get x minus 7 times x minus 7 plus 0. Clean this up a little bit, and you get y is equal to 2 times x minus 7 squared. That's the form we're going to work from. This is going to open up in the positive y direction because it's a y equals parabola and the 2 is positive. The vertex is going to be 7, 0. The 7 is with the x, so it contributes to the x value of the vertex. And there's a plus 0 at the end, which we don't see, and that's our y value. So when I plot this, 7, 0, opening up, just a little sketch. We don't have to do the other pieces, the focus, the directrix, the focal chord endpoints. It's not asking for that. It is asking for the line of symmetry, which cuts right down the middle through the focus and the vertex, which is going to be x equals 7. It asks for the number of x-intercepts, which it touches the x-axis only one time at the vertex, and the number of y-intercepts. Now the way I graphed this, it doesn't look like, well, what I had graphed is not touching the y-axis, but those arrows mean that they're going to continue to move to the left and to the right, so eventually the left side of that will cross the y-axis in one spot. So number 8, part A, we're supposed to find the vertex of the given equation. We need to first put it into vertex form. We do that by solving for the variable that's not squared, which is -y. So I'm going to first add y to both sides of the equation. Switch that, or turn that equation around so y is on the right hand or left hand side. And now we need to factor out a 2 from the part with the x. So we end up with y is equal to 2 times x squared plus 8x. Leave a little room to complete the square. Take the 8, cut it in half, and square it, which is 4 squared, or 16. That's what we want to add. But when you add 16, you're really adding 2 times 16, which is 32. So we need to compensate by subtracting 32. So when next step we factor. So y is equal to 2 times, so when you factor that you get x plus 4 times another x plus 4, which is x plus 4 squared, and then 7 minus 32 is negative 25. So now we can see that our vertex is going to be negative 4, taken from, that's our x value, taken from the x minus, or x plus 4 squared, and then negative 25. For part B, where we need to write it in either focal width form or vertex slash descriptive form, I'm going to do the second one. That's how we learned it in our class. And we solve for the variable that's not squared. So 4x minus 3, we're going to solve for x. But before I do that, notice the y squared plus 8y, we need to complete the square there. So we take the 8, cut it in half, and square it, which is 4 squared, or 16. So we're going to add 16, and then subtract 16. So we end up with 4x minus 3 is, when you factor that, you get y plus 4 times y plus 4, which is y plus 4 squared, minus 16. Now I'm going to add 3 to both sides to solve for x. And when you add 3, you get minus 13. And remember, there's a 1 in front of the parentheses. So when you divide by 4, you get x is 1/4 times y plus 4 squared minus 13 divided by 4. And that is what we were trying to, that's the form we were trying to get it in. Part C, we want to do the same thing, get it into vertex form. I need to solve for x. I'm going to flip the equation around and put the 5x plus 60 on the left-hand side. Put the 3y squared minus 18y on the right-hand side. I'm going to first focus on completing the square. So first factor out a 3 from the 3y squared and the negative 18y. Leave a little room to complete the square. Take negative 6, cut it in half, and square it, which is 9. So I want to add 9 here, which is really adding 27. So I need to compensate by subtracting 27. Factor this. We still have 5x plus 60. In this case, equal now to 3 times y minus 3 times y minus 3 minus 27. Get x by itself now by subtracting 60, and we get 5x is equal to 3 times y minus 3 squared minus, well, we had negative 27. Now we're subtracting 60, so now we have negative 87. And lastly, divide by 5. You divide the 3 by 5, and you divide the 87 by 5. And that is the form we want. Part D, we're asked to write the equation of a circle with a center at 7, negative 5, and a radius at 5 root 3. So that's going to be x minus 7 squared plus x plus 5 squared. You take the opposite of your x and y values, is equal to, and make sure you square the 5 root 3. When you square the 5, you get 25. When you square the root 3, you get times 3, which is going to give you 25 times 3, which is 75. So, and then just repeat the left-hand side. E. What is the formal definition of a circle? It is the set of all points that are equidistant, or means the same distance, from the center, which is a point called the center. What is the formal definition of a parabola? It's the set of all points the same distance or equidistant from both the focus and the directrix. And remember, the focus is a point, the directrix is a line. Here the center is a point. And that's it for the review.